the problem what you have shared, right?
Yes.
Suppose the data that is encoded by a sequence of zeros and ones. When the data is transmitted, it is possible that 0 could be swapped with 1. That is actually, for instance, if I have 0, 1, 0, 1, 1, so there is a possibility that 0 can become 1 or 1 can become 0. In order to check this, if this has happened, an extra digit or bit is appended to the beginning of the sequence in the following way. If the number of ones in a sequence is odd, like for example here 1, 1, 1, that is odd, then that bit what we add, it is 0. Okay. Otherwise, if it is even, then we add 1. Okay. For example, if we want to transmit 0, 1, 0, 1, 1, 1, then here number of bits is even, so we should add 1, correct?
Yes, sir. So two
At the
zeros is
beginning.
this.
No, we are not counting zeros, number of ones, right? So here it is
Yes.
1, even ones. So whether it is like number of ones are even or odd, based on that we identify whether we have to transmit 0 or 1. So here it is even. So we have to add the parity bit as 1. So that's why like at the
1.
beginning we have to add. So that's where like it is 1, 0, 1, 0, 1, 1, 1. I got it, right?
Yes, sir.
Okay. So this extra digit is added on the beginning of the sequence known as odd parity bit. Similarly, there is an even parity bit. In the case the number of ones in the original sequence is even, then 0. If the number of ones is odd, then we append 1. Okay, that is even parity. Okay. So here, suppose you receive a sequence 1, 0, 0, 1, 1, 1, 0. So here we know first bit is actually the parity bit, rest is the data bit, and they are saying it is odd parity, correct?
Yes.
Okay. So in the odd parity, when the number of ones is odd, if the number of ones is odd, then we add 0. If the number of ones is even, then we add 1. Here if you see, number of ones is what? Odd.
Odd.
And it is odd parity, so it should have been 0. So that's where actually it is like we are seeing some error. There is error basically.
Error. Yes, sir.
Okay. So are you able to determine their locations in the string numbers? So parity check, right? Parity check is only error detection code. It cannot correct the error. So it is like we cannot able to detect where is the location, because anywhere it can be, right?
Yes, sir.
Okay. So now if it is like 1, 0, 0, 1, 1, 1, 0, now they are saying now it is actually even parity. So even in the even parity, if you see here, even parity, if number of ones in the original sequence is even, then 0 we have to transmit. If the number of ones is odd, then we have to send 1, correct?
Yes, sir.
So here basically number of ones is odd and we transmitted 1, correct?
Yes, sir.
So that's where it is correct. The transmission is right, so there is no error. Okay.
So number of ones is odd, we add 0, right, sir?
No. If
Like previous.
in the even parity, in this case, the number of ones is, so they are saying even parity. Previously it was odd parity. See, there are two parity ways. One is odd parity. If it is like you are following odd parity, then if the number of ones is odd, okay, if you see here odd parity, if the number of ones in the sequence is odd, then we send 0.
Yes, sir.
If number of ones is even, then we send 1. It is in odd parity. So here number of ones were odd parity. But what we sent? We sent 1. That is error. Correct?
Yes, sir.
In the even parity, if the number of ones is even, then I send 0. The number of ones is odd, then I send 1. So here number of ones is odd, and I sent 1. That is correct.
One. Yes. Yes, sir.
That's where there is no error.
No error. Yes, sir.
Okay. But can you know for sure that error has not occurred? Okay. No, I cannot say that there is no error occurred. I cannot say that, because if there is actually 2 bits or more than 1 bits, more than here even number of bits are split, more than 1 bits and even number of bits are split, then I will not be able to identify. Correct?
Yes, sir.
So if these both are like, if it was 0 and it became 0 0, so now it is also odd parity only, even parity only. So it is only 1. So more than 1 bit is erroneous, then I am not able to detect. So here they have mentioned explain, right? You have to mention that if more than 1 bit, or like if here if even number of errors are occurred, then I will not be able to identify.
Yes, sir.
So using the above answers, explain why parity bit error detection is not always reliable. You have to explain, like if both, this example you have to say, you have to show that like if both bits are flipped, what will happen?
Yes, sir.
Okay. So and you have to explain why this technique can't be used for error correction. You have to say, see now here I can able to say that whether there is an error or not. That too it is not reliably, but I cannot correct it. I mean, I will not be able to know where the location of that error is, right?
Yes, sir.
That is why it cannot be used for error correction.
Yes, sir.
Clear, right?
Yes, sir.
So we saw that yesterday, controlled accesses, right? Before that, like we saw.
Yes.
Yeah, CSM basically.
So in that, what is P persistent and I persistent? Sir?
In which one? Aloha.
CSMA, sir.
Yeah. So in I persistent, right? So what exactly we will be doing? Here actually, see, we will be sensing the channel and sending. So in case of I persistent method, I will sense the channel. Okay. If I find that that line is idle, okay, then I will send the packet immediately without waiting anything. Okay. And with the probability I, okay, whatever the data I send, with the probability I will send. But it is immediately, as soon as I sense, I will send immediately. But in case of P persistent, what I will do, I'll detect the channel. If I find idle, then what I do, I will not send immediately. I will wait for the slot, my slot, and in that slot I will send.
Yes, sir.
Hope you got it.
Yes, sir.
Okay. Today we will talk a little bit about controlled access. Okay.
Yes.
So here in the controlled access, right? I mean, previously in the CSMA or Aloha protocols and all, we were actually dealing with the channels. So if the channel I find it is free, I immediately send the data, right? I mean, we had various methods. But here in the controlled access, it's not about channel. It is like station to station communicates each other and coordinate the communication.
Yes.
Okay. So here one station cannot send the data unless another station is authorized. Okay. It has been authorized by other station. So in this controlled access, we have three types: reservation, polling, and token passing. So in this reservation, right, if a station, for example, any transmitter, if he want to send the data, then he has to make the reservation before sending the data.
Yes, sir.
Okay. So each time, the total time, right, it is divided into intervals,
Yes.
different intervals. Okay.
Yes.
So I mean, whenever I reserve, right? So I reserve those time intervals. How many time slot I want to reserve, right? So that many time interval I will reserve. Okay.
Yes.
If there is n station in the time, n station in the system, so then there will be total n different reservation slots where I can reserve. Okay.
Yes. Yes.
So whenever one station wants to send a data, it makes a reservation in its own mini slot. Like he will have a slot, right? So he will say that in this slot I will send the data, or whether he will not send the data. Okay.
Yes, sir.
When the station, if it is not doesn't make any reservation in that slot, so I mean, like that can send at any time. I mean, at that slot, right? Any other station can use and send the data. Okay, so it is purely based on reservation.
Yes.
So I can put the screenshot of that. You can see here we have various frames. Like there are 5 stations, 0, 1, 2, 3, like, and he will reserve slot 1, and like whenever there is like 3 slots has to be reserved, then like 1. After that 1, right? So you see here, like if you reserve 4, 3, 1, then 4, 3, and it will not send the data of the second slot immediately. Like if it is not reserved, then wherever it is reserved, that slot it will send. So it is a
Yes, sir.
kind of polling way. I mean, like based on like whichever the slot is reserved, only those data we will be sending. Okay.
Yes.
Next way is polling. In polling, right? Actually, we will be sending some packets. Okay. We will be keep sending the packets, and we will poll for the acknowledgement to check. So whether those channels are clean. So this actually has to be used some in some topologies, mesh star, right? In that kind of topology. Okay.
Yes.
So the primary device control the link. So whatever the primary device is there, right, he will control the link. And whatever primary device says, only the secondary devices they will just follow the instruction.
Yes.
Okay. So whenever some session has to happen, then only the primary will be initiating the session. Okay. So the secondaries doesn't have any role here.
Yes.
One image based demonstration. So if you see here, the primary it started select, then acknowledgement came. It will send the data acknowledgement. So again, primary will initiate poll, and no acknowledgement came. Then it will try to send for the next one whether any polling in the sense he will check any data is there from A to send. So if there is any data, he will send the acknowledgement. If there is no data, he will send the no acknowledgement. So after that, it will poll B station. If there is any data, he will send and send back the acknowledgement. If there is no data, he will also send NAC. Clear?
Yes, sir. Yes, sir.
So next is actually token passing protocol. So it is actually from one device to another. So here, always right, the chance of losing the data is less. But here we will always have the privacy concerns involved. So especially, so we use right the logical ring protocols for the token passing. So in a sense, whenever you want to send the data to 3, to go to 2, then from 2 to 3 it will go. So collision possibility itself is not there. If you want to send data to 4, so here to here, here to here, here to here. But there is a delay, right? And the security issues also.
Yes.
I mean, because this second guy also will read, third guy also will read, right? So
Yes,
this
sir.
is actually this kind of mechanism we call it as token pass.
Yes, sir.
Next important, especially in the communication also, channelization protocols. So three types of channels are there. One is frequency division, multiple access. Next is time division, multiple access. Finally, port division, multiple. So especially nowadays in mobile and all, you might have heard about auctioning, right? Auctioning, the spectrum auctioning. Like they say,
Yes.
Geo buy this band to this band, Reliance, the Airtel buys like from this band to this band. That is nothing but
Yes.
we will have like various frequencies in the environment, right? So if you see your Wi-Fi devices, those are all actually working at around 5 gigahertz. Okay, it may be 20 megahertz bandwidth. Now, FDMA, like we have multiple users, right? So maybe like if I consider each user has 10 kilobits per second data, what they will do, this 10 kilohertz, right? So they will, each user will send in the different frequencies, different frequencies, so that there is no interference. Like if both the guys are sending at the same frequency, there's a possibility of interference. So the FDMA, that is a frequency division multiple access, for each user we split the frequencies. Getting?
Yes, sir.
Okay. In case of TDMA, here the same frequency. If I say 20 megahertz, same frequency. But the data, if I have n number of user, I will split the time. So if I have 10 users, first 1 second I will send user 1, user 2, so on up to 10. At the 10th second, I will send the data of user 10.
Yes, sir.
Okay. Next, final one is actually code division multiple access. So here, for example, if I have 3 users, okay, maybe I'll be sending at the, like, see, CDMA always used along with the TDMA and FDMA. Okay, if I have 3 users, then what I will do, I will have some data of user 1, user 2, user 3. So this data I will multiply with a special code that is called pseudo random code. Pseudo random code. And finally, each one I'll multiply with a PR code and I will add it. Okay. So if I directly add, the data will be correct. So after multiplying with the pseudo random code, if I add it, then what will happen at the receiver end? Whenever I multiply those code with the same pseudo random code, then I will be able to regenerate the original signal. Are you getting?
Yes, sir.
Yes. So that mechanism is actually CDMA. Here we are dividing the data using codes. That's why it is called code division multiple access.
Yes.
Okay. Yeah, this is fine. So maybe today we will pause the session. So tomorrow we will work on other layers. So next is which layer?
Network layer. Network layer.
Yes. Network layer we will see. Okay.
Yes.
This flow what I am following, it's fine with you.
Yes, sir.
Because
Yes, no,
few of
sir.
the unnecessary information I am skipping, whichever is like relevant for your exams. So I am highlighting those points. I am trying to make you
Yes.
understand those points. Okay. If you feel that
Yes,
like
sir.
today, for instance, like you had a doubt like I persistent and P persistent. So whenever you read, whenever you have this kind of doubts, you please bring to me. We can discuss more on this. Okay.
Yes, sir.
Okay. Thank you.
Thank you.